As the chair mentioned, my presentation today will involve energy use, climate change, which also means risk analysis. So just to see how awake everyone is this morning at this early hour, let's start with a quiz. I'm a professor, so we have to have a small test. If you know the answer, please speak up fairly quickly. Put your arm up and I'll recognize it. This one is a little bit difficult question. Where was the first commercial oil well in North America dug? It was actually the first one in the world, and they had the first geyser anywhere in the world where oil came shooting out of the ground. Of course, the name of the game today is we're trying to reduce the amount of oil and fossil fuels that are used. Anybody want to guess? Just guess the location. That's close enough. Just take a guess. Any? Okay, this one I'll tell you the answer. It was actually in Ontario. It's a place called Oil Springs near Sarnia, 1858. That was 1 year before Penn State in the American state of Pennsylvania also discovered oil. And a lot of the engineers and people who were involved with this went to Saudi Arabia and many other countries of the world at the start of that oil revolution. Here's another one. Which country produces the most hydroelectric power? Somebody said China. Who was that? That gentleman over here? You said China? Who said China? I think it was that gentleman. Come up to this front here. You get a prize. Nobody's claiming they said China. Okay, well, who was the person who said China? We need you up in the... Oh, come here, yeah. Don't be shy. Come to the front. No, not chocolate. No. So what we have here, it's like a 5 yen. It's a good luck Canadian dollar piece with a Canada Goose on it.
Thank you.
Congratulations. What is your name?
Samet.
And you're working in what area?
I'm working in water resources.
Oh, water resources with Professor Takara?
Yes, he's my boss.
He gets a raise. Congratulations.
Thank you.
Okay. So it's actually China, surprisingly, since the open... Yeah, round of applause for that young man. Surprisingly, it's actually China. Let's see here. And Brazil and Canada are both the same. The United States also has a lot of hydroelectric power, but since the three gorges came into operation, China became the largest. Which country produces the most nuclear power as a proportion of its total electricity generation? Who said France? Oh, come to the front, please. That's correct. It's France. So France produces a lot of nuclear power. I think it's in the range of, 75% comes from nuclear. Please tell them your name. We have So he's actually from Indonesia. So what I really like, too, about DPRI, it's such an international place. Yesterday we had people from Indonesia, Mexico, Canada, I think 4 other countries with just a group of 8 people. So this is a tough question, of course. Canada also has a lot of nuclear power. There are some dangers, as of course Japan is aware, but then what is the trade-off? What are the dangers if we destroy the meteorological system from releasing fossil fuels? Which country produces the most wind power as a proportion of its total electricity generation? No. Denmark. Who said Denmark? Oh. The others were a good guess, by the way. Okay, this actually has a Canada goose on one side, the national bird, and then Queen Elizabeth on the other. Your name?
I'm Professor from this institute.
And what is your group?
Earthquake.
Oh, earthquake. Oh, yes. Okay. Nice to meet you.
Nice to meet you. Thank you.
Yeah, very good. Which energy source produces the most greenhouse gases when the total life cycle is taken into account? Which energy source? It's a pretty dirty one. Coal, that's right. Who said coal? Ah. Don't be shy. That's right. Coal is a pretty dirty product, and we're trying to get out of it as fast as we can, of course. I'll mention in my talk in Ontario, we did close down all our coal-generating plants. Hi. Nice to meet you. Congratulations.
Thank you very much.
What is your name?
My name is Kamo.
Kamo. And your research group?
Over 10 years I was here in the same environment.
Environmental engineering. Okay. Very good. Yeah, thank you very much. Okay, just a couple more here. So coal, that of course is very dirty, and we got to get out of that business as fast as we can. There on the far right in that graph, that shows the, relatively speaking, the amount of greenhouse gas releases per unit of energy power, and you can see that coal is very high in the far right. Which type of vehicle tends to be the most polluting in the eastern United States? It's also true of Japan. It's also the most polluting vehicle here. Guess? The most polluting vehicle on the road right now in the eastern United States. This is, say, I'll give you a hint. It has to do with passenger cars. What is the most polluting type of vehicle you could drive in Japan in the eastern United States? Any guesses? Mexico's very quiet today. Sorry? Couldn't hear it. Train? No. No, let's say vehicles on the road, not trains. Actually, in Japan, it's true. Trains is also badly polluting right now. Think about it for a minute. Which vehicle is most polluting? Sorry? Electric car. Who said that? Somebody say electric car? Oh, I thought they did. Anyway, I gave you the answer, I guess. It's actually the electric car, because when you plug it into the wall here in Japan, of course, all of your electricity comes from fossil fuels, coal and oil, and so therefore it's the most polluting vehicle on the road in terms of greenhouse gases. One of the recommendations we make in our report that I'm going to speak about in a few minutes in Canada is we have to decarbonize the electrical grid. Otherwise, it's meaningless to produce electrical cars if electricity comes from coal and oil. Okay, we're getting close to the end here. One of the ways I'll mention that we're thinking about in Canada to cut back in greenhouse gas releases is through a carbon tax. Which country was the first to introduce a carbon tax? Any guesses? The first to produce a carbon tax. I'll give you a hint. It's in Northern Europe. Denmark? No. Okay, here it is right here. It's Finland. So Finland was the first. Now in Canada, we have done a good job to a certain point. We could be doing a much better job in cutting back in greenhouse gases. But which state or province was the first to introduce a carbon tax in North America? Unfortunately, we don't have a uniform policy in cutting back in greenhouse gases, but there has been the odd jurisdiction. And which province or state was the first? No, that's a good guess, because they've been very advanced in cutting back in pollution from vehicles, because they have to breathe the air. Any other guesses? California is bringing in a cap and trade with the province of Quebec. La belle province de Canada. Okay, that's the hint right there. It's actually Quebec. But it wasn't a very large tax, and one of the examples that they use worldwide, and other provinces had actually produced a very effective tax on fossil fuel use. Does anybody know what province that is? This is in Canada this time. Quebec had a tax, but it wasn't a very high tax. A province in Canada is very, very popular for Asian tourists. Who wants to guess? It's towards the western part of Canada. Sorry? Couldn't hear that. I'll assume you said British Columbia, so come to the front. There it is right there. So the far west coast there, it's actually British Columbia, and they've had a significant reduction in the greenhouse gas releases by bringing in a carbon tax. They actually then reduced the income tax of citizens in the province of British Columbia. They used the tax for that purpose. Now somebody said British Columbia there, didn't they? Maybe not. Okay. Here's one final question. This also is one of the key findings of our report, which I'll outline in a few minutes. What is the most difficult problem to overcome for society to drastically reduce greenhouse gas releases? What do you think is the most difficult part? Just take a guess. Sorry? Speak up. What did the person say there? I couldn't hear you. Anybody want to guess? The most difficult problem to overcome. I'll give you a hint. We have the physical systems problems. You know, we have to generate electricity. It might release greenhouse gases. It affects the environment, the climate system. It also affects society. All that combined, what do you think the most difficult problem is? Okay, here it is right here. An economy-wide policy. So this we think is the most difficult hurdle of all. Of course, as you know, in December they had the meeting in Paris. The good news was they said, well, let's go to 1.5 degree maximum increase instead of 2. But very unfortunately, there's no international legally binding agreement to cut back in greenhouse gas releases. Without this, the evidence shows that it's not going to happen. We do need some sort of agreement economy-wide. Now, the countries have said from Paris, well, they're going to go back to their countries and then try to reduce to a certain level. But the problem is, if it isn't binding, what we found, what's happened historically, is a good chance it may not occur. So that's the end of the quiz. Let me go on now to the talk. So this is the presentation right here. When I received an email from DPRI, and they kindly said we'd like to offer you the DPR award, which I was very honored to accept, they said, could you come with some type of presentation that might connect with the interests of DPRI? And I can't think of anything that really involves such high risk as energy use and climate change. You know, the saying is that energy policy is environmental policy is energy policy, and of course all of this involves extremely high risk. The risk is so high that we could, seriously degrade our climate system and it may never recover. So a very important problem. I know there are people here at DPRI who are looking at it. It not only affects the climate system, it affects our water resources, it affects our agriculture, it affects the economy. Very, very tough type of problem. So in Canada, we have what are called expert panels. You have similar things in Japan here through your Science Council of Japan. In China, you have the Academy of Sciences where they take on a lot of big projects. United Kingdom, they have the Royal Society where they take on big projects. And we do the same thing in Canada. Just move ahead here. So what happened is that industry came along. It was actually Magna Corporation. It's a car parts manufacturing company, about 130,000 employees. Its headquarters is in Ontario, but it has plants all over the world. They said, well, we know there's a problem with climate change. We're not sure what it is, but we'd like to pay for an expert panel to take a look at the current evidence and what is the best thing we could do here in Canada especially. So I'm going to tell the story about Canada, and I prefer to do that because you can then decide, of course, in your own countries, whether it's Japan, China, Germany, what is the best approach for you. So they came along, they gave us a charge known as fact-based synthesis for the general public, what's happening with our energy system in Canada and North America as a whole. What are the technologies that are available? Any energy sources and technologies? What are public policies we could use to reduce the greenhouse gas emissions? And challenges and opportunities for transitioning to a low-carbon energy system, and learning from policies implemented to date. So that whole thing of evidence-based was so important. It's nice to say theoretically, here's probably a good way to take a look at the problem, but what does the evidence say? So here, by the way, I will leave a copy of this presentation. If you'd like one, you're most welcome to have it. Let me tell you the final answer first. So we had our charge. We had to take a look at energy use and climate change in Canada, and what can we do about it? So here are the overall 3 findings. So let me just mention those first, and then I'll go back and give you some details. We have a 150-page report, which you can download free of charge, and I've left a copy here, a PDF version, which you're most welcome to have. But here are the overall findings. First of all, finding number 1, Canada could achieve major emission reductions with the adoption of commercially available technologies. In other words, it's all there right now. It's on the shelf, ready to go. One of the comments of some of the people on our panel were that things have changed drastically in the last 20 years. For example, windmill electricity, solar cell electricity, nuclear power plants, all of these have dropped significantly in price, and the technologies have improved a lot. So there are technologies out there that we can use immediately for cutting back in greenhouse gas releases, which means closing down our coal-fired plants or oil-fired plants and things like that. So that's finding number 1. I should mention we do encourage continuing research, of course, but you have to be careful because sometimes you'll get the impression that they're waiting for the big technology fix. That's down the road. Let's put lots of money into research. That just isn't going to occur. It's probably going to be a basket full of different technologies, and we have to start adopting them immediately. Of course, we want to do research into further technologies like carbon capture and storage, which I'll mention in a few minutes. So that's finding number 1. Very good news. We have all of the physical systems answers right there, right now. Number 2, low emissions electricity system is a foundation for having a good energy system within a country. A nice way to say that is decarbonize the grid. So you have to get rid of your fossil fuel generation plants. Like I said a few minutes ago, in Ontario, the province of Ontario, we've actually gotten rid of all our coal-fired plants. It costs money, but it was manageable. Just the example of the electrical car. If you have a fossil fuel grid to produce electricity and you have electrical cars, well, of course it's totally useless because it doesn't do anything. You're still putting lots of greenhouse gases into the atmosphere. Number 3, a transition to a low-emission energy system is achievable with the right combination of stringent and flexible policies. So notice the first 2 are more of the sort of the physical system solutions. We have lots of technologies available for producing electricity. We have electrical cars. There are all sorts of good technologies. Number 2, we have to decarbonize the grid. But to really make this effective, we need economy-wide policies. Very, very important. Unfortunately, that still does not exist globally, and very few countries have an economy-wide policy. So let me just say a little bit more about that with respect to Canada. Let's see here. So notice up here the word stringent. Let me just explain what we mean by that. When we say stringent, we mean fixed. So if we want to reach, let's say, 1.5 degrees C, we can transfer that transform that into what that means in gigatons per year and cutting back in carbon releases. And then, of course, over a certain time period, let's say maybe 1 or 2 decades, you have to cut back very significantly. That we cannot bend at all. If you go above 2 degrees C, it's 100% certain from the climate change scientists that we're going to have very, very dramatic effects on climate. The only uncertainty now, have we passed the point of no return? In other words, is it irreversible? So we have that overall objective, very, very highly significant cutbacks. We have to be stringent. Now, the word flexible, what that means is there are many ways you can use different technologies. So in Japan, for example, your set of technology uses might be quite different from Canada or Germany. Okay, that's up to you as a country, how you decide to cut back. Also, you may decide to use different types of policies. Later on, I'll mention a little bit about carbon tax. That's extremely simple because you have all the systems in place. People may prefer cap and trade, command and control, or probably a combination of the policies. But once again, you can be flexible on the policies, except for the fact they have to be, as mentioned here, economy-wide. So it has to go across the entire economy, or in other words, the entire country and internationally. So rigorous, compulsory, economy-wide emission reduction strategies are essential. Why do I say that? Well, the evidence shows it simply doesn't work if you don't have it. So we certainly need agreements. I know Japan has worked very hard over the years in order to get a worldwide agreement. Unfortunately, they still failed in Paris, as you know. Very unfortunate, because we had everything in place there. The countries were excited, they wanted to do something. Then unfortunately, they never made it stringent. In other words, it wasn't legally binding. Now, hopefully that will change. I hope that is the case. Now, here's the good news down here. This, once again, is based on the available evidence. Canada could reduce emissions from 60 to 90% at manageable cost. How do we know that? There are lots of studies that have been carried out. They're referenced in our report. Even the IPCC has a section on this in their report. The Stern report from the United Kingdom, and we've had reports within Canada. Of course, some organizations who are entrenched in the current system will say it's far too expensive. We'll just say that's nonsense. It simply doesn't say that. The costs are manageable. So that then is an overview of what's in the report. So if you fall asleep, please don't snore during the rest of the presentation. But those are the main ideas. 3 key findings. We have the technologies. They're on the shelf right now. Many of the technologies you build right here in Japan. Number 2, we have to decarbonize the grid. And number 3, we need these economy-wide policies. Probably that's the most difficult one, and it's the one that has not been implemented yet. So let me now say a few words about these different findings. First of all, let me introduce you to our panel. These people came from all different backgrounds. Paul Portney used to be head of resources for the future in Washington, D.C., and then he's also a professor at the University of Arizona. He and I chaired this committee, but the people came from different backgrounds: economics, public policy, engineering, business, sociologies, energy systems, and technologies. So the group of scientists who selected the panel decided this is definitely an interdisciplinary problem. Ira, you were mentioning yesterday in your talk the way problems are so interdisciplinary when it comes to risk analysis. Underlying this entire thing, as I mentioned, is the whole idea of risk analysis in systems thinking. What did we do? We had to address the problem, so that's all underlying the findings that we came up with. How many have been to the city of Ottawa? Anybody visit Ottawa in Canada? So anyway, we had a number of meetings in Ottawa. We had 3 meetings there. That's Terry Fox. He was a young man 30 years ago who got cancer, and he decided to run across the country to raise money, and he made it halfway, and then unfortunately his cancer overcame him. So he became a national hero, and his statue is right in front of the Parliament buildings in Ottawa. Here's one of our hotels, the Chateau Laurier in Ottawa, where we had some of our meetings. Let's skip a few of these. This is Don Walker. He's the CEO of Magna Corporation. As I mentioned, they gave $500,000 for this study. By the way, the scientists and everybody in the panel worked free of charge. It's a pretty good deal for the country. The same thing happens in Japan. At your Science Council of Japan, in the Japan Academy, a lot of the best scientists will work on various projects. So anyway, he's a mechanical engineering grad from Waterloo, and he's now president of that company. Here's our setup then in Canada when it comes to the expert panel reports. This organization here just has 3 organizations as members. They might get money from the federal government or from industry. Here's a problem of national concern. Down here we have the Royal Society of Canada. The closest thing to this is your Japan Academy in Japan. The Academy of Sciences within this. We also have the Canadian Academy of Engineering, the Canadian Academy of Health Sciences. So they may choose experts from those academies or anywhere in the country, or for that matter, anywhere in the world. So they then had a panel which decided, well, let's put together this expert panel. I think I'll just skip a few slides. Take a look now at a map of Canada. Let me just outline the energy situation. So here then on the east coast, we have Newfoundland and Labrador, then the province of Quebec. These 2 provinces have a lot of hydroelectrical power. So does the province of Ontario, Manitoba, and British Columbia in the Rocky Mountains. So we have 1, 2, 3, 4, 5 provinces, 5 out of 10 have a lot of hydroelectric power. We could actually double the amount of hydroelectric power in Canada. So in that sense, we're in a very strong position to cut back in greenhouse gas releases. Where we run into a problem is the province of Alberta, where our oil is. Second largest reserves in the world, possibly the largest. A lot of it is in the oil sands in Saskatchewan. And out here in New Brunswick and Nova Scotia have coal-fired plants. So sort of this part here and this part here is where they have to sort of try to cut back quite a bit on greenhouse gas releases when it comes to energy generation. Of course, vehicles and other types of energy uses, that applies across the economy. I'll just skip a few here. Now this, by the way, this is close to that oil springs that I mentioned. This John Henry Fairbanks, this is the world's oldest oil company, 1858. They still actually have some oil coming out of the ground, but there isn't very much. But it's still in operation. And that's a little operation. That's on some farmer's land. He gets maybe 50 barrels of oil a day, and then the Esso truck comes along and collects it. Okay, let's take a look now at the different findings. So finding number 1, once again, Canada could achieve major emission reductions with the adoption of commercially available technologies. So here's a nice summary of how to put this into perspective. So take a look at these 3 baskets here. On the left we have energy efficiency. So this is reducing the amount of energy required to perform a task. So they gave me a nice office in the 5th floor here. There's a refrigerator on it. I open it up and there's a little index there. It says this is a very efficient refrigerator. It's well insulated. Takes far less electricity to cool the refrigerator compared to earlier models. So in almost everything you can have some type of efficiency. And of course this is very important. Automobiles, all sorts of efficiency in terms of petrol use over the last 30 years. The problem is that nature looks at total accumulation. So when it comes to greenhouse gas releases, it's the total amount. It's not sort of the amount per let's say, gross national product, reducing that amount of energy per gross national product. It's not intensity, it's the total amount. So this is sort of more like intensity, less energy per unit of object that's used. But it's still part of the solution. So energy efficiency. Over here we have energy substitution. This is switching to renewable and low-emitting energy sources such as nuclear, hydroelectric power. This is where a lot of work has to be done. As I mentioned, in the province of Ontario, we've closed down all our coal-fired plants. So a very important area right here. Now this one over here, carbon capture and storage, this is where they take the CO2 or methane, whatever gas it is, greenhouse gas, and pump it underground. In a sense, this should be a very small box. The technology there is just evolving. We know a lot about the technology, but it's very expensive. So at the present time, there's not a wide-scale use of carbon capture and storage, but I'll mention a couple of nice projects in a minute. So those then are the 3 main areas. So what we did in the report, we took a look at energy use for electricity generation, the source of the energy, like coal or natural gas, nuclear power, water for hydroelectric power, etc. We also took a look at transportation, we took a look at buildings, and we took a look at industry uses of energy and where we can actually cut back in greenhouse gas emissions. Let me just give you a few slides. We do have a lot of details, as I mentioned, in the report, so you're welcome to take a look at it. The report, by the way, is written for general public use, but we still give a fair amount of details, but try to explain it qualitatively. So transportation, this is the fastest growing source of emissions. In North America, we have a serious problem. There's high growth in road freight transportation. Our railway system, for example, could be dramatically improved, especially transportation for people. Over 120 years ago, we had the most advanced railway system in the world. We built a 5,000-kilometer railway to join the country together, and now we have one of the most primitive railway systems. So, for example, that's where Canada could achieve a lot of efficiencies. I'd like to travel from Toronto to Waterloo to Toronto. It's about 120 kilometers. I should be there in 20 minutes. Instead, I get caught in traffic for 2.5 hours. So we have areas in transportation where we could improve dramatically within Canada. Road, rail, aviation, marine transportation in North America all rely on fossil fuels. Okay, so of course if we switch to electrical trains and cars and then produce our energy without using fossil fuels, we'd be in good shape. So we can have efficiency gains across all modes of transportation, increase reliance on vehicles powered by low-emission electricity for passenger light vehicle transportation. Many Japanese cars, such as a Prius, are extremely popular because they're very efficient on energy use in terms of fossil fuels. Expansion of biofuel use in freight transportation. That's a big one for Canada. Urban planning, land use planning, infrastructure investments consistent with efficiency, low-emission transportation systems. So all sorts of recommendations there regarding transportation. I'm going to skip ahead to another slide here just to save a bit of time. As I mentioned, we do look at buildings, and with buildings we found that generally speaking there have been a lot of improvements over the last 20 years in buildings. We could do better things like cogeneration. You know, you share heat and electricity within sort of a block of a city where everything's connected together, and all sorts of things like that. But let me mention a little bit about carbon capture and storage, just to make that more clear. So what happens there is, let's say we have some type of CO2 source. In Western Canada, we have what are called the oil sands. It requires a lot of energy to push the oil out of the ground. They actually put pipes underground, pump steam down, and the steam melts the bitumen and pushes it to the surface, and then they take it away. That requires a lot of energy, and a lot of CO2 is released. So what they can do is try to capture that CO2. Then they have to transport it somewhere, usually by pipeline. Then there's injection. So if you're on land, it goes deep down into the earth. And then finally, in the far right there, we have measurement, monitoring, and verification. A lot of people are afraid of carbon capture and storage because they think the CO2 will leak. So that's why we need measurements and monitoring. So what are some of the requirements? We need concentrated streams of CO2, and we need proximity to geological storage. What are the barriers? Very expensive. Supporting infrastructure, and public acceptance is a big one. So let me tell you about two success stories. Now this I was pleased to learn. This all happened in Canada. These are the two big success stories with carbon capture and storage. One of them is in the province of Saskatchewan. It's called the Boundary Dam. It's actually a coal-fired plant, but for some reason it has the name the Boundary Dam. It's the first commercial-scale carbon capture and storage application for a coal-fired plant anywhere in the world. Now, a lot of you have probably heard the oil companies talking about carbon capture and storage in the United States. You know, the electrical utilities where they use coal talking about it, but they haven't done anything. So that's what I mean. Well, you have to put money into research, but you have to make sure that you actually implement the technology. Just don't say you're going to do it in the future. So here then, they actually did implement it at the Boundary Dam in Saskatchewan. They do have some problems with it. It's at a fairly large scale. They pump the CO2 underground, and then they use it to push oil to the surface. So in other words, there's a commercial use for that CO2. And that's one reason why this is sort of working. That just opened about a year ago. A second one is the Shell Quest project in the province of Alberta. This is the first commercial scale application of carbon capture and storage in the oil sands. As I mentioned, in the oil sands, all that it means is the oil is mixed with sand. They pump steam deep down into the ground, and then it melts the bitumen. This is oil with sand, and it pushes it to the surface, so a lot of the sand doesn't go with it, and then they take it away. Well, that requires a lot of CO2, so they're capturing that CO2 from the oil sands upgrading. So those are the only two. I think Norway has something that they've done on a small scale, but those are the only two worldwide that we're aware of, even though all of these companies have been talking about carbon capture and storage for a long time. So if they talk about the technology, they have to be able to implement it now so we can get moving, on cutting back in CO2 releases. We sort of think that probably this could be a solution at isolated locations. At the current time, it's hard to imagine it on a wide scale because the CO2 releases are just simply too massive. Okay, let me move on. So let me say a little bit about key finding number 2. Key finding number 1, we have the technology there. We can do a lot right now. In the report, we mentioned the things we could do with buildings, industry, transportation, and some other related areas. So key finding number 2 then is we have to decarbonize the grid. Here's a chart then that sort of shows what's happening in Canada. What we have along the x-axis on the left are the provinces from the west coast to the east. So BC, that's British Columbia, Alberta, Saskatchewan, Manitoba, all the way over on the right there to Newfoundland and Labrador. So here then, this is the generation intensity. This is grams of CO2 per equivalent kilowatt hour. So here then is 2012 versus 1990. So notice Alberta and Saskatchewan, relatively speaking, are still the polluting provinces when it comes to CO2 releases because of their fossil fuel reserves. They have a lot of fossil fuels, as I mentioned. Manitoba has a lot of hydroelectric power, no oil. Ontario, notice the big drop here in 2012. That's because Ontario very recently closed down all of its coal-fired plants. See, Quebec, hydroelectric power, lots of it. New Brunswick and Nova Scotia depend on coal-fired plants. And over here we have Newfoundland and Labrador, which has a lot of hydroelectric power. So when I take a look at a chart like this, we actually felt pretty good. I thought the situation was much worse than it actually was in Canada until you take a look at the evidence. Okay, I'll just repeat a few things that I said verbally before. So hydroelectric power, it's a source of the majority of Canada's energy. So like Brazil, we have a lot of our electricity that comes from water. Dominant electricity source in these provinces right here, as I mentioned before. And we can actually double our hydroelectric power capability. Nuclear, it's the largest electrical source in Ontario. We actually have a very good nuclear technology. It was started after World War II. Canada elected not to build nuclear weapons. We could have done this in 1946. We purposely said we'd only use them for peaceful purposes. We have something called the Candu Reactor. It's a heavy water reactor. It has a lot of big advantages. It's the safest reactor built anywhere. It can operate using thorium. It can eat nuclear weapons. And it can also use the fuel from the traditional type of power plants like you have in Japan and the United States. It can actually use that spent fuel and get more energy out of it. So it's actually a very good design, and it was developed by the Atomic Energy of Canada. So in Ontario, we have a lot of nuclear power, also in Quebec and New Brunswick. So as I mentioned then, in some of these provinces here then, the western provinces and two of the eastern provinces, they have a lot of fossil fuels. And there's rapid growth in solar and wind-generated electricity, especially in Ontario. Let me now say a little bit about finding number 3. So finding number 1, we have the technologies right now. We can cut back dramatically on a worldwide basis. We have to decarbonize the grid. And then probably the most important point and the most difficult is we need an economy-wide policies, or set of policies, let's say. They have to be stringent. We have to actually meet those targets. But we can be flexible in the combination of policies and the combinations of technologies to reach our goal. Here's some good news within Canada. Carbon taxes in British Columbia. This is used as an example around the world of a political jurisdiction where they brought in a carbon tax, and there was about a 17% reduction in CO2 releases by fossil fuels. Cap and trade, Quebec is proposing a cap and trade system with California. They did have a bit of a tax earlier on, as I mentioned, but they seem to be going in this direction. We have to have flexible regulations. We have federal regulations for passenger vehicles. There's something called renewable portfolio standards, where you sort of go across an industry and overall they have to cut back. And then down here, the command and control, we have the traditional energy efficiency type standards. You know, like my refrigerator in room 522 on the floor up there. I'm sure that was some type of standard that the Japanese government put into effect. So this is sort of good news. In fact, we are doing some things that are doing them well, but we still have to do a much better job. So we have quite a few pages, I think 50 pages, where we take a look at different types of policies. There are a whole slew of them, and it's sort of going to be like a toolbox. You know, you have your toolbox here that you carry, and there'll be a lot of policies which you have to connect together in order to have some sort of economy-wide set of policies that are effective. So just taking a look at, I'll just look at 2 items briefly, carbon tax and tax and trade, but cap and trade rather, but we do look at a lot of other policies in the book and compare them. So what are some of the strengths of, let's say, carbon taxes? Well, cost certainty, cost effectiveness, the bureaucracy is already in place. You probably have people monitoring sites where they take energy out of the ground. So in Canada, we know where the energy comes from. We can easily tax it right at the site, for example. Revenues can be used to reduce other taxes or alter distributional impacts of the carbon tax. In the United States, James Hansen has recommended what he calls fee and dividend. That's a tax, then the money that you get from the tax, you actually pay in a check to the citizens of the United States. So one example that he gives in his book, if there were a $100 per ton tax, every family in the United States each year would get a $10,000 check from the government, and then you as a consumer decide what to do with that money. So in other words, they can make it tax neutral. What are some of the weaknesses? Uncertainty and emission reductions. So maybe you should have, for example, a tax and cap. Okay, right now, for example, oil prices have dropped a lot, so is adding it, let's say, a 50% tax going to mean very much when the price is so low? So that's why you need a combination of policies. And sometimes in the right-wing countries, it can be politically divisive. Let's just take a look at cap and trade. What are some of the advantages and drawbacks? Strengths, emission reduction certainty, because what they mean by cap, total amount released each year within, let's say, a political jurisdiction, then each year they push down the cap, and then like a stock market, the companies buy their rights to pollute. In other words, to release CO2. But every year, the total rights that are traded reduce in amount. So that's why they call it cap and trade. Well, they think it's could be cost effective because it doesn't cost the taxpayer anything. And you could use the revenues to reduce taxes and things like that. There are some major weaknesses, however. This has been widely criticized because there aren't a lot of examples where it's worked well. They've used it in other areas of environmental pollution. So there's uncertain compliance cost. You know, how do you really check if the companies have cut back? If you're taxing, let's say, energy at a source, let's say where the oil comes out of the ground in Alberta, that's very clear. You know, you see the tax right there. But then when the companies say that they're going to cut back, or for that matter, government-owned power plants, how do you really check? So you have to have monitoring and compliance. Big administrative burden, transportation costs, vulnerable to lobbying pressure. And this is what the evidence has said, where they use cap and trade for other types of pollution. So all of the different approaches do have their benefits and drawbacks, but as I mentioned, it'll probably be some sort of overall combination. Let me skip 2 slides here. Choosing policies. What are sort of the basket of policies that you could select? What we're trying to do, by the way, here, I don't mention the word directly, we're really trying to reduce risk very, very dramatically, because the risk of climate change is just, and the hazards involved are just so, huge that we have to do something about it. So you could express this, of course, totally in risk terms. But here are some of the criteria that could be used, and like I say, you could put risk reduction here. It's really reflected in all of these. Environmental effectiveness, cost effectiveness, distributional fairness, administrative feasibility, political acceptability. You can have a whole set of different types of criteria that you could use to judge whether a policy is working. Of course, most importantly, you better be meeting your objective. So we have another figure that we put in the book. It's given right here. What are some of the key policy design features? I mentioned specific types of policies, tax, cap and trade, and there are a lot of others that we compare in the book. But what are some of the overall design features? Well, here are some that we thought were important. Just starting at the top and going, let's say, around this way, around the clock. Linking policies to binding and stringent emission limitation. So important, that word stringent. I mean, you got to meet that or we're in big trouble, society. When they had I flew over in a Dreamliner 787 Boeing aircraft from Toronto to Haneda a week ago. Well, it's a great aircraft, but you remember they had problems with the batteries. They sort of had this complex battery system and something they call an emergent property. Well, for some reason, it caught on fire. It was very unexpected. It wasn't in their calculations. Well, you don't say, well, we'll figure that out 5 years from now. In the meantime, 20 airplanes crash. You fix it right away. And, of course, Boeing did fix the problem. Well, it's the same here. This type of thing where you have policies and they don't really work. Well, you got to fix them, period, because this is a very serious situation. So we call that being adaptive. If policies aren't working, you have to adapt them to make sure that they meet the objective. Another one here, just going around, including monitoring penalty provisions, providing compliance flexibility, treating new and existing firms fairly, harmonizing policies in a very important one. In Canada, it's more like a federal republic, like Germany. And there, the provinces have a lot of power. And so we have to harmonize across the provinces. Places like France and Japan and China, where you have a lot of central control, in many ways it's easier to implement this type of thing. Compensating groups adversely impacted by the policies. You have to somehow help the losers in this whole process. Involving the public in decision making, we think, is extremely important. A lot of excellent papers have been written here at DPRI on the importance of making sure that stakeholder value systems are reflected in everything what you do. Whether it's something like climate change, how you respond to earthquakes and tsunamis, you better make sure that you're looking at the value systems of the different stakeholders. Okay, I'll just do 2 more slides. I see it's getting close to 1:45. And let me skip ahead here. So just sort of trying to summarize here near the end. With careful design, Canada could implement stringent climate policies without compromising economic well-being. And this is not even taken into account all the types of spin-off industries that you'll get by the technologies that sell more because we want to cut back in GHG releases. Just given the current system, the costs are manageable. They're not very great. However, it does cost somewhat more to cut back. And because it costs more, that's why you need policy. Because within industry, the profit margin is so small worldwide that if it's going to cost money, I mean, they simply can't afford to do it. As simple as that. So that's why I need policy, so everybody's playing on the same level field. Industry doesn't care. As long as everybody's playing in the same level playing field, in this case, let's say, if you have a carbon tax, you know, and it's fair across the system, then it's fine. They don't mind at all. So it does cost something, but it's manageable. The good news here, once again, is that Canada could cut back 60 to 90% at manageable costs. That's real good news. And I think that applies to most countries around the world. Of course, some of the countries that are underdeveloped, as they agreed in Paris, we have to help those countries in order to bring into effect better technologies. They simply can't afford it. But let's say countries, you know, who are reasonably well developed, the costs are very manageable. And let me just finish in this slide right here. If you want to download a copy of the report, it's about 150 pages. You can just go to this site right here to download that report on energy use and climate change. I've also left a PDF version here and also a copy of all the overheads. I only used about a third of them, just to give you a summary. So you're most welcome to have a copy of that if you'd like one later on. So let me just say in closing, I selected this topic because it certainly involves high risk. The Disaster Prevention Research Institute, I know, is taking a look at climate change and many other types of interconnected problems and all sorts of natural hazards. And risk, of course, is at the basis of all this. And if you take a look at the world in general, our systems are so stressed. I mean, the massive populations in places like China and India, even Japan, you think the population is high, but it's even more concentrated in those countries. I mean, this is stressing all of our societal and physical systems to the limit, and a lot of risk involved in a whole slew of different types of problems. So I really think this whole approach then sort of the risk, let me just use the word risk reduction, I think is a very important one, and I congratulate DPRI for certainly being a world leader in this whole area. So I'll stop there. Thank you.